In this example, I'm going to explain how you can solve this indeterminate beam problem with two fixed ends and a load that disappears at x equals a. And it's a UDL. So first, I have opened my integration program, INUN. Let me erase all the explanations as comments. And let's ignore this because it's a fresh program that I started. But you better actually save it. So let's assume that you have saved it as some other file name. Okay. And step one is statics. So you look at the loads and you formulate your static equations. So the first equation is called E1. I'm going to use my keyboard here. E1 is colon equal to the force equilibrium, which says all the upward load, I've assumed two upward loads, RA or B. These are my unknowns. So the sum of them will be equal to all the downward loads. So RA plus RB minus Q newtons per meter times A meters. So Q times A. Don't forget the multiplication sign. Equals 0. Okay, that's my force equilibrium. E2, my second static equation, is a moment equation. So I have to assume some directions for my reaction moment. I'm going to assume that this MA is anticlockwise, while this M sub B, the reaction moment due to the right-hand wall on the beam, is clockwise. And I'm going to assume one direction to be positive for the moment equation. So what I'm doing is a summation of moment equals 0. And I'm going to assume anticlockwise positive. So M sub A will be a positive contribution in the moment equation, minus M sub B, okay, because it's assumed clockwise, M sub B. And then what else do I have? I'm taking moments about point A, so RA doesn't matter. And Q times A is the force that will cause a clockwise moment. So it's a negative contribution. So negative Q times A, which is the total amount of force. And from statics, you know that we can pretend it's acting at the centroid of those UDL. So it's got a moment arm of A over 2, right? So A over 2. And let's not forget that there's also R sub B that is occupying a moment arm of L. And it's a positive moment contribution because it's generating a counterclockwise moment, R sub B times L. So it's a plus, oops, I need to go back to my calculator, plus, oops, plus RB times L equals 0. That finishes building the equation. Of course, we cannot solve these two equations at the time because we have actually 4 unknowns. So let's continue as usual with our integration for bending moment and deflection, carrying those unknowns with us. So you got to know how to model this load. This is a distributed load, Q, but it needs to disappear once X goes beyond A. So that's how you model it. Okay, so W, my load function of X, is equal to Q, a constant, times, nevertheless, the fact that it has to disappear requires some step function. So 1 minus h of X minus A, right? Because when X goes beyond A, the step function is turned on and deducted from 1, so you get 0 left, okay, in W, once X goes beyond the required A meters. So that's the load, and V the shear, okay, let me just remind you, we look at the left-hand end, you've got RA coming up already, so immediately you need to have a initial value for the shear to balance that coming down. So V has to be equal to its initial value, which is R sub A, it's an unknown, but that's quite fine, plus the integral, which you can use my program to perform because now you're integrating some step function. So don't forget it's minus W that we integrate. That's a V, it involves a step function. And now let us go to the next part, which is the moment as a function of X. And again, let's look at the left-hand side. Okay, you already have M sub A, the reaction moment provided by the wall on the beam, which is assumed to be anticlockwise. And also, internally, this M sub 0, get the initial value of the bending moment, we always assume on the right-hand side of a cut, a positive or a anticlockwise positive moment. So these two must negate each other to keep this piece, infinitesimally thin piece in balance. So in other words, M sub 0 has to be negative M sub A. Okay, so that's my initial value. So M is going to be its initial value, negative MA, okay, whatever it is. We still need to solve for the exact value of MA. But MA is positive, then M0 is negative, okay. So the change in M when you go to a distance X is going to be given by the integral of V, which you can do using my calculator program. So that's M, the bending moment function. We don't stop here because we need to go on and obtain Y as a deflection curve. So first we solve for EIY prime. Okay, so that's done here. We are really doing EIY prime. And that's equal to the integral of M, okay? You may ask, where is the constant term? Well, if you think about a constant term, it should be 0 because it is EI y prime at 0. And that's the slope at 0. So we know because it's fixed, slope starts at 0. So there is no constant C1. And all we need to do in this case is just integral of M. EIY then is the integral of EIY prime. Oops. So we integrate EIY prime expression. Again, because the deflection has to be 0 at x equals 0, we need no constant term here. Okay, so C2 is also 0. So that's all we need to do for EIY. Okay, then you can do all kinds of things. For example, you can substitute x equals L for the slope at B. So let's call it slope B. The right-hand end is going to be EIY. That's a general solution for Y. But let's evaluate it with this vertical bar for evaluation of x being L. Okay, at the right-hand end, that is the slope at the right-hand end. What about the deflection at the right-hand end? Or we can call it, let's go just simply dB, okay? dB is equal to EIY. Oops, I made a mistake, sorry about that. Here I should be using EIY prime because that's the slope, okay? That was a mistake. Okay, now let's get the deflection dB is equal to EIY at B, so x value is L over there. But we see that h of L minus A appears. L is bigger than A. So I know this is a 1. Okay, so let's put that in as a fact, okay, into a variable fact, which is for making substitutions. Whenever you see h of L minus A, substitute it with 1. Okay, so that's a substitution rule that I'm building because I need to use it multiple times. So I put it in a variable called fact. Okay. Now, what do we want to do? That's the final step. We want to get all the unknowns solved for. So you've got 4 unknowns, right? What are your unknowns at this point? The 2 reaction forces and 2 reaction moments. You need 4 equations. You already had 2 equations. They were called E1 and E2. Now you know you have to use the remaining boundary conditions, okay? And those will be things I have not used, which is the slope and also the deflection at B are both vanishing. So I am going to, okay, let me show you what happens if I slope at B. Is this object that I know must be 0, but you see I have this mess here that I know should be 1. So I can make a substitution, okay, using the fact. Then you see this part disappears. Okay, so I'm going to use these 2 quantities, slope at B and delta at B, the deflection at B, and give them 0 values for my 3rd and 4th equation. So let me actually do it step by step. Equation 3 will say that this slope, okay, now as a trick or maybe useful trick, you put the 0 on the left-hand side. That is totally fine for building equations, but do not put it on the right-hand side because you know what does it mean when you say fact equals 0? Okay, it may be misunderstood. So 0 equals this whole thing, slope with fact being substituted. So let's see what happens. Okay, so that's my equation E3. Okay, actually let's try it the other way. Slope given fact equals 0. You may get an error message, okay, or nothing useful happens. Okay, so this is another trick. Okay, you should try to remember. Okay, when you build equations like this, better put 0 on the left-hand side, okay, to avoid confusion. So my final equation will be that the deflection at B is a 0 also. And I want to get rid of the step functions in the deflection expression using the fact that I used. So that's a rather long-looking equation. Okay, so now let me solve. Okay, here you have the solve command, or you can just type it in if you're using the computer version. Solve command. Solve equation 1 and equation 2. The AND word can also be found here under the book key. Or you can just type in equation 2 and equation 3 and equation 4. Oops. Comma. What do you want to solve for? It's those unknown reactions, or A, or B, MA, MB. Okay, so here are your complete solution. Let's take a look at it. It is a bit long, so I would definitely recommend that you do it using some kind of software. I mean, since people are using ChatGPT to write their emails, why don't we use technology to do algebra, okay? To see you've got the answers for the 4 reaction forces and moments. So I think the algebra would be a bit tedious if you use the pencil and paper approach. Okay, so that's the end of this solution process. We'll explain the plotting in another video. So let's just pause the video for now so that there's a short YouTube video later for you to watch.